Well, how are you doing? Okay, this video is going to be hopefully a game changer. There's two effects that I intend on showing um, the real world version of. There is um, many examples of this regular. Everyone sees it regular every day. But there are two effects that are opposition on the globe outside, seem to constantly not want to know about. They hand wave away these effects. They try and say they're not real. They don't want to know about them. Basically, they're a problem because their Earth curve claims originated with these two effects. And this photograph we have here um, displays these two effects excellently. But the problem we have is due to the dimensions of things here with the mountains and size of them, the distance, all kinds of things. Um, it's very difficult to have that argument with our opposition because they they don't want to accept visual effects because everything has to be earth core for them. All there's no such thing as an obstruction. There's no such thing as an occultation or how things can appear lower than your eye line, even though they're at the same height as your eye line. Things like that. They can't accept those kind of things. It's a real uphill battle with them. They don't want to know about anything like that because the problem is, as soon as they start accepting that these effects are real, as soon as they start to actually stop hand waving them away, that means that they actually have to start looking at things differently then, and they can't just jump straight to Earth curve. Because at one time, our opposition used to claim that inferior mirage was Earth curve, that things had gone behind the curve of the Earth, of the globe Earth, because they had just gone into a band of inferior mirage. And strangely enough, one of the main people that brought this photo to our attention is the very person who disproved that claim back in 2016, 2017, around there. So it's really bizarre that that person has decided to now claim that this is globe earth proof when we can't find any. This was flat earth proof. So I'm going to show with this video how and why it's flat earth proof. And I'm also going to give two things that, if they are investigated and accepted by our own flat earth community, then they will be, because I've been trying to speak about them for years now, then they will be battle tools of the future that I really don't see how our opposition are going to deal with them. How are they going to get past these? They can't. So all they can do at present is hand wave them away because there's not enough people bringing them to them and putting them in their faces and saying, look, this is because of that. That happens because of this. You know, what you're claiming is there's no evidence for. You know, they need a geometric horizon for things to go over. You know, they need that. You know, they don't have it. And they're not going to have it. It doesn't exist. And they're trying to claim now that a refracted horizon is what things go over, which is complete nonsense. As their refracted horizon, their refraction is based on the R value that is based on the measurement of the geometric horizon that we can't see due to the refraction, yada, 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 nonsense. Okay. So for this photograph, I just want to show some things here, right? Now, this is the angular size calculation I got off the tower off of this person here. Right? You all know who this is. In a debate I had with that person, and it's 0.48362. Now, when I did the calculation, I got slightly less. I got 0.47646. So this is like the calculation up here is actually better. You could say better if we were going to have an angular size change argument. It would be better than this. But the truth is, I got this one, and through the angular size change calculator, or angular size calculator. So the Dale Craig angular size calculation I got was 0.53313. So I'm going to use this one and the Dale Craig one. Okay, globe Earth's angular size calculation after curvature calculations have been taken into account, because you must do the curvature calculations and then do the angular size calculation on the remaining visible above what would be their geometric horizon, the very thing they don't have. But that's still what you have to do. And for that, it came out at 0.27357. So on the globe Earth, right, I just want to go back down. On the globe Earth, if you look at here, 0.27, 0.27357. And this is the flat Earth calculation of 0.47646, right? So this is less than half of that, okay? So this is the Dow-Craig calculation or angular size calculation on a globe, and this is the angular size calculation, sorry, for Blackpool Tower, right? So what we should be seeing, if we just go to here a second, so I'm just going to annotate here a second. Let's take a line here. I'm going to make it a bit smaller than that. It's very big. Right, that'll do. Okay, so if we take, I'm going to actually make it slightly thinner so you can get an even better view of it. Hopefully you can see it. So the full height of the tower is from, it's actually not including the spire, it's about here to there. So half of that, what is half of that? So maybe, is it about there? Is that about half? Am I even being generous? So that's where the globe Earth's Dow-Craig, top of Dow-Craig should be, just there. No, but it's up here. Now, right, it should be here on the globe Earth. That's where it should be, somewhere down here. Because this is about half, and that's another half, all the way down to the shore. Okay, because all the elevations are taken off of mean sea level. So it could even be actually slightly less than that if this is actually slightly above mean sea level. But let's just put it here, thereabouts, right? Let's put it there. So you have all this mountain here that is being ignored by our globeside opponents. They keep on wanting to speak about how the mountain should be up here, right, above the tower. So if we just come back here a second, it's correct. The angular size of the mountain is 0.53313 on the flat Earth, right, and it's obviously more than 0.47646 for the tower. Okay. So, but they want to ignore this down here, 0.27357. They want to ignore that completely and just claim because the mountain looks smaller in height than the tower, then that means globe. But all they've done is basic trigonometry. They took these two figures and just ran with it. It's like there's no refractive or visual effects taken into account whatsoever. So if we just come down here, the flat Earth deficit, right? So this is the deficit. So if we subtract this figure here from this figure, so 0.47646 subtracted from 0.53313, the deficit is 0.05667. So it's 0.0 and then 5667. That's really going into the small figures, right? But if we do the same with the globe's 0.27357, and if we do the same calculation, right, the difference is 0.20289. So the globe's deficit is 0.20289. The flat Earth's deficit is 0.05667. So all we have to account for is 0.05667. Now, a lot of the calculators won't even go further than 3 numbers, you know. So, and a lot of them you can just choose just to have 2. So if it was just 2, it would be 0.05, and the globe would be 0.20. You know, so it's nonsense. Like, they won't address these things at all. The deficit between the both flat and globe is 0.14622. So the globe is 0.20289 and the flat Earth is 0.05667. So, I mean, the difference is this globe calculation here of 0.20289, like that is the amount that's the globe Earth is missing, basically, and this is the amount the flat Earth is missing. I mean, their calculations are ridiculous, the way that they try to the logic they're using is just crazy. But anyway, look, the whole point of this video is that all this stuff here, yeah, we can argue about it, but we won't need to. Okay, I'll show you why. So I'm going to minimize that, and I'm going to take this. Now, this is a video I took right in recent days from a cemetery, not too far away from my home, and these are mountains here that are 25.24 miles away. I'm just going to play it here. I'll zoom in to the mountains. Now, because it's heading for sundown, and because of it being obstructed there in the foreground, right, I didn't zoom very well, but it's all the same. You can see them. Right. Now, that's all you need to see, right, of that. So I'm just going to go, right, so there are the mountains. We can see 1, 2, 3, okay, so the big one here, big peak, smaller and smaller again, right. This one here is actually slightly behind these two. So there are the 3 peaks. You can see how much of them we can see, right? I'm at an elevation of 142 feet. This here, this obstruction, is 165 feet. And the mountain is 2,342 feet. So come back down again, and we're going to go back to this a second, right? So I'm just going to press play on this. This is the first thing I showed people when that it's going to go back here. So watch this. This is just visual. This is called visual occultation. Okay, it's the very first thing I showed when this other Blackpool photograph was shown. As the bigger jar moves back, it's occulted by the smaller pepper thing here in the foreground. And that's what's happening in the Blackpool photo, because the angle of the camera, it does not allow the photographer to see above the tower and to see that deficit of that small amount of 0.02 whatever of the mountain that would be higher in angular size, but it's not allowing us to see that because the angle is basically, the mountain is so far back that the person ends up looking at the sky above the tower, right? So just play this on a second. I'm going to move that, you'll be able to see. Move it down a second. So I'll move it there now. And you can see that it's occulting it. Even though it's on a flat plane, it's occulting it. I move it back in, and there you go, right? It changes back more into its actual size as opposed to its angular size. So back out again. Watch it as it comes back in. I'm just going to see, right? It's just an effect, but it's a real world effect, and it's going on in this photograph right here, right? So, right, what are we going to do, right? What did I do, right, when it came to this observation, right? What is different about this one? Well, the mountain is actually almost the same size, right? So I'm just going to go into here, right? Now, there is where I was at the cemetery, Ballygunner Cemetery, in it's just outside Waterford City, and here is the mountain over here, okay? This is 1, 2, 3 mountains here, okay? There I am at 142 feet, and this is at 2,342. Just says 2339 here, but it's actually 2,342. Okay, so I'm going to come down, right? So that's how much of the mountains we can see. See this yellow line going across here? This is just the elevation profile line. This split line here is the amount of the mountain that we can actually see after obstruction. Okay. Now, if you can just see down here, you can see. See, I'm just going to go in a bit. You can see how the mountain comes down and it hits this land here, and this land is still way above sea level. Just to show that these lines here are just part of what Google Earth puts in, and that's not the ground. So we're seeing this much of the mountain, right? Of these 3 peaks here, we're seeing this much of it, right? This is the highest one. This is 2,342 feet, okay? So on to the next one. There we are, just showing again with the red, right? So this is how much we're seeing. If you can just see this shaded area here. And if you can just see this line here where the shade starts. So it's 1,000 foot. So we're not seeing anything of the mountain up until we're up 1,000 foot in elevation. So the first part of the mountain we see is 1,000 foot up, right? Due to the occultation that's in front of us. I'm going to show here. Sorry. Due to this occultation in front of us, this is a mile away. Due to that, we can't see a huge amount of this mountain. Okay, we're not seeing it for like that's actually. It's going to show again. We're not seeing that up. There's 1,000 foot. Right? I'm not even adding in the houses, just the basic land. We're not seeing only up. There's 1,000 foot of the mountain up here. Okay, so we have to go up 1,000 foot before we're able to see any of the mountain. Okay, on to the next, the next slide. So this is the line of sight. Now this is an orthographic view, and obviously, if you look at this with these diagrams, I mess around with them, but the thing about the profile diagrams on the elevation profile diagrams on the Google Earth is they have to fit whatever distance you put in, right? They have to fit the whole lot within that diagram. So our line of sight here, right, is starting here at 142 feet. This is 165 feet, and our line of sight comes up here, and in the diagram it's hitting the mountain about here, right? Which is probably about almost correct, right? But the difference is we have all the rest of this mountain up here, right? So that's 1,000 foot up. So if you can see here, if I just come across this line, there's 1,000 foot. But there's still 1,342 feet of the mountain above that. But when we look at this, what are we seeing? That doesn't look like 1,342 feet, does it? Right? But it actually is, right? But why is that? Why does it look so low? It's because of optical drop. Because I'm making, basically my eye line is making a parallel with mean sea level. Mean sea level, like optical drop proves that the sea is flat, regardless of undulations and waves and whatever else. The sea and sea level is flat, not curved, right? Not level with the center of a sphere, any that nonsense. It's flat and level, horizontal, flat. Okay, this is optical drop, and I'm going to prove it in a minute. So right now, I'm sure there's people who are on the opposition side looking at this video going, this is nonsense, right? This is after dropping down because of the curve of the earth. Because this is the first place these people go to. It's always the curve of the earth. It's always the curve of the earth. They cannot see past that. But they won't be able to go use that in this argument, or in this video, that argument with this video. So that's the line of sight. This is how much is being occulted, right? I'm just going to show, right, so here we are, this blue box, right, at 850 feet, because I'm given my feet height 142, and I'm not 8 foot tall, so with the camera on top of that, I just said to round it off, I'd say 850, up to that 1,000 foot. So I'm 140, let's say, about 147, 8 feet. My camera height is above mean sea level. And here is another 850 feet up to 1,000 feet. So this whole area here, we can't see, right, due to visual occultation. We're not seeing all that down there. We're not seeing all that due to visual occultation, right? The very thing, these are two effects, visual occultation and optical drop, are the very two things that the globe Earth side have completely hand-waved away. They won't deal with it. And this is why they won't deal with it. They want to be able to claim that this mountain has gone over the curve of the earth, right? But it can't be, according to their mathematics and according to reality. So I'm just going to move on. So here, so remaining amount visible after occultation has been taken into account is 1,342 feet. But extracting the globe's hidden amount, which is only 75.6 feet, we have 1,266.4 feet, or 0.4. Well, I'm just going to show there, right? Right. Globe's hidden, geometric hidden, 75.6 feet, right? Viewer height in feet, 142 feet. Distance in miles, 25.24 miles. 75.6 feet. Okay, that's all the globe's hidden is for that distance at 142 feet. So we just come back here again. So that means there's 1,266 266.4 feet, right, and 850 feet that the globe can't account for. All the globe can account for with their mathematics is 76, just under 76 feet. That's it. That's all they can account for. So obviously, it's not Earth curve, is it? It can't be globe Earth curve. It can't be any of those things. They're just the mathematics. They don't have their mathematics don't allow for it. So we're going to move on. Okay, so the globe Earth cannot account for anything outside the confines of the green box, which is just down here. Okay, as globe Earth geometry does not account for any visual effects of perspective, i.e., visual occultation, optical drop, angular size change, etc. As globe Earth mathematics only account for a drop and hidden value, and only within the confines of its own geometry. So at 142 feet, looking to this mountain at 25.24 miles away, this little green box there is the only amount that the globe Earth can actually calculate for. Okay, they do not, visual occultation and optical drop have no place in their model. Right? Neither is angular size change or any of these things. The model is purely mathematical. And their maths can account for this little green area, and that's it only. So I'm just going to move on. Now, the observer's actual direct eye line is always going to match their actual elevation eye line, which in this case is 142 feet, okay, which is this purple arrow down here, okay. But their perceived apparent direct eye line will always be higher than their actual direct eye line due to the visual effect of optical drop, which in this case appears to be causing a perceived direct eye line as high or maybe even higher than 800 feet in elevation. Optical drop is a visual effect caused by an observer making an optical parallel with a flat surface, and in reality that flat surface is mean sea level. The effect is a dual combination of this optical parallel and angular size change at a distance. So the purple line here is the observers, which would be my actual real world direct eye line, right? This is 142 feet over here. This is 142 feet here, okay? But the red arrow is pointing to where it appears I'm looking at, which is here. Right now it's probably higher than that, and I have that 800 foot, but it's actually probably higher. But I brought it down a bit because the visual occultation causes me to look up slightly, to tilt the camera up slightly, or well, not tilt the camera, but my eye line to go up. My direct eye line is here, right? This is my direct eye line, somewhere here, right? But, right, so visual occultation causes the view to the mountains in the back to be tilted up a bit. Your eye line has to be tilted up a bit, but my direct eye line is right here. Okay? It's now in reality, right? In reality, it looks like this is already halfway up the mountain, right? But that's only optical drop. Angular size change causes optical drop, which means something of your direct eye line can appear to be lower than your direct eye line. Okay, that's what optical drop is. I can demonstrate it, I can explain it, I can show it, I can show, this is only one of many observations I can get, and other observations I got of other people with details of optical drop. It's always been seen, but it's ignored by the ball side, by the globe side, just like visual occultation. So my direct eye line is somewhere here. Now visual occultation causes my eye line to be up this way, but my direct eye line is here, which is still 1,800 to 1,000 foot up the mountain. But yet I'm only at 142 feet. So the red arrow is where my perceived eye line is, but the purple arrow is where my actual eye line is. So this is the apparent eye line, and this is the actual eye line. So just going to move on. Within the confines of the diagram, my eye line appears to be meeting about halfway up the full height of the mountain. But in reality, my eye line was even higher due to visual occultation, or at least appears that way as the mountain appears dropped in my view, due to optical drop of the full actual absolute height of the mountain over the distance of 25.24 miles, two effects not taken into account within globe Earth geometry. So I'm just going to show here. This is something I've done with the elevation profiles off of the other Blackpool photograph. So this is the occultation point here, right? This is 165 foot. I'm at 142 feet. So this is the occultation point here, right? And my oil line is hitting the mountain about here, right? And as we showed earlier, right? As I showed earlier, you have, right, all this area here, right, that obviously appears way down lower, right? And it's nothing to do with Earth curve, or curve of a globe Earth, because that's the only thing they can account for. So when I come back to here, if you take this mountain, right, these are actual, so this mountain here is not going to be this close to me here, right? Because I'd never be able to see so far up it if it was that close to me. But because of angular size change at a distance, and because of visual occultation and obviously optical drop, which is due to me making a parallel with mean sea level, I know that's going to be difficult for people to understand, but optical drop proves without a shadow of a doubt that mean sea level is 100% flat, not curved or anything like that. It's 100% sea level, flat, horizontal level, flat, right? This effect proves it. So the globe Earth, right, it can't account for only 76 feet of this. So my oil line, yeah, it appears to be meeting about halfway. So even if we use full actual size here, right, of this mountain, right, and my oil line is being occulted here and it's coming up here. If we move this mountain back like that and don't even change its actual size, so we're doing this purely orthographically and not front on perspective view. What happens is that as the mountain moves back, right, my oil line doesn't change. My oil line stays the same at the same angle, and eventually my oil line will go over the top of that mountain. Now, the mountain is not far back enough. At me at 142 feet elevation, the mountain would have to be further back than 25.24 miles for me to end up seeing over the top of it. But if I was down lower, like in, let's just say, this photograph, and the mountain is here, this Dale Craig here, this is not much higher than the mountain I'm showing, right? This is about close on the same height, it's a little bit lower, but close on the same height as Dale Craig. It's heading for the same height as Dale Craig. This Dale Craig is 50 miles away. This here, right, is 158 meters. Okay? Dale Craig is 763. This is 158, and the photographer, right, is only at, they say, somewhere between 18 and 24 feet, somewhere like that, right? So this is 500, and this is including the spoiler, it's 526, but it's given the height of 518 feet. So if you think of it like that, there's about 500 feet of this tower over the photographer, and it's 12 miles away, 12.2, and then behind that, another let's say 38, is it, or something like that, miles after that is the mountain. So the mountain's 51 miles away. So if you take visual occultation and optical drop into account, how is he ever going to look over the top of that tower and see the top of that mountain? It's never ever going to happen. It has nothing to do with any Earth curve or any radius values that they don't have because they don't have a geometric horizon. It has nothing to do with any of that. It's purely optical drop and visual occultation. That's why over on this side, we are seeing basically straight across, with the exception of the diffraction limit that's going to take place and our visual angle being so tight, we're seeing basically to the very bottom. And you can see other photographs that show this over here, and they're showing it looks exactly like that. We're seeing basically across there to the bottom. And past this point here, there's some water here, just past this point. This piece of land here, I think, is slightly higher. It's slightly up a little bit, but it don't matter. We're seeing right over to the base of the mountains over there. So this has nothing to do with Earth curve. This is visual occultation, right? Causing the photographer to see only sky up here, and optical drop causing the mountains to appear lower in the distance. This is not orthographic, this is perspective view. And this here proves it, because there's only 76 feet of that mountain can be accounted for by the globe model. So the globe has no answer for this. There's no way out of this for the globe. With this, they can argue nonsense, right? And they'll try and keep it within this part of the photograph. But they can't argue with this. There's no argument here. You can't beat this. It's a done deal. So I'm just going to come back to here. So as you can see, if I move that mountain here that I'm looking at in my observation back the same distance as Dale Craig, and even though I'm at 142 feet, which is, you're talking 120 feet higher than Kevin Jackson, the photographer, was in the Blackpool photograph, you tell me that I won't end up looking over the top of the mountain, or that the mountain was not going to be occulted by this here, which is only a mile away. It's 1 mile from me, and yet 1 mile away, and it's occulted. It's 1 mile away, and it's only I think it's 23 feet above me, and that's not even including my camera height. So it's actually slightly less, probably about 18 feet above me, and even at that, I'm being occulted, and I can't see all the mountain. Why? Visual occultation. That's why. It's been known by photographers for a long time. They even they sometimes call it that, and they sometimes call it upward angle or something like that. I can't remember the name of it now, but they have a different name on it. But they don't account for optical drop as much. But they know what these things are because they see them all the time. But they just don't ask questions about them. So I'll put this down. Oh, sorry, one more second. Back there a second. So yeah, my point being, sorry, I got a bit ahead of myself, that this mountain, move that back another 26 miles, the same distance as Dale Craig is from the photographer, and you tell me I won't end up seeing over the top of it? You're joking me. You tell me that won't be occulted by that what's in front of me? It will be. There's my occultation point. Now, okay, the occultation point's a bit closer to me, but it's also still only, it's only a mile away, but it's still only 18 feet above me. So if you make that 500 feet, make it 12 miles away, and put the mountain another 26 miles back, you tell me I'm going to see the top of the mountain? I'm not going to see the top of the mountain. It's ridiculous to even think that it'll happen. It won't happen. It's an impossibility. So, just final details. Okay, optical drop and visual occultation proof. Observer height, 142 feet. Mountain height, 2,342 feet. Mountain distance from observer, 25.24 miles. Globes geometric hidden, 75.6 feet. Globes visible after hidden amount extracted, 2,266.4 feet. Flat earth angular size at distance 1.0069. Globe earth angular size at distance 0.97437. So there's hardly anything in the angular size difference. So height of obstruction, 165 feet. Angular size of obstruction, oh sorry, I had that wrong. I put in that wrong. Don't mind that one. I know I forgot. I meant to change that earlier. That don't matter anyway. Amount actually hidden due to visual occultation, 850 feet. Because I'm about close on 150 feet above sea level, and there's 850 feet hidden before I see 1,000 foot up the mountain. Remaining visible after occultation, 1,342 feet. So this is 1,342 feet. That's the remaining visible. Okay? After occultation, which is blocked out 1,000 foot, or let's say, because I'm at close on 150 foot, it's blocked out 850 foot of the mountain. So remaining visible after occultation, 1,342 feet. Remaining visible after occultation and globe curve calculations taken into account, 1,266.4 feet that the globe can't account for. Okay, deficit between, well, the globe certainly can't account for this 850 foot. Deficit between observer height and obstruction height, 23 feet, more like 18 and given 5 foot camera height. Distance between observer and obstruction, 1 mile. So 850 foot, right, can't be accounted for by the globe, and neither can, right, 1,266 foot, which is what this is. They can't say this has gone down over the curve of the earth because there's only 76 feet of globe obstruction, right, possible. And this here, according to them, should be up in the air here. But it's not. Why not? Because of visual occultation and optical drop, which causes it to, my direct eye line here, right, is looking over at a place that's 1,000 foot up. When my direct eye line, it appears that way, but my direct eye line is actually at 142 feet down at the bottom of the mountain. Okay, so we can conclude that 23 feet of obstruction right, can visually block 850 feet of the mountain when the observer is only 1 mile from the obstruction and 25.24 miles from the mountain. And remember, the above calculation is working within a Google Earth elevation profile diagram, which distorts the true distances between observer and obstruction and the mountain, and the observer and the mountain. So the true hidden amount of hidden land elevation due to the optical effect of visual occultation may actually be more than the diagram represents. So I'm saying 850 feet. It looks kind of about that, but it very likely is more, right? So what is also extremely prevalent in this observation is the visual effect of optical drop. As the observer's elevation of 142 feet and their apparent direct eye line are not in balance, as the apparent eye line of the observer is 800 foot and more. But the observer's actual direct eye line is still only 142 feet. So due to the observer's direct eye line making an optical parallel with mean sea level, and the effect of angular size change at distance, it appears that the observer's direct eye line is at least 650 feet above their actual direct eye line elevation of 142 feet. So it appears that my direct eye line, and I'm dropping it down a bit, it's more than that I would say, definitely, but I'm dropping it down, right, is due to optical drop, is 650 feet, at least 650 feet above my real actual direct eye line. So this is my apparent, right, direct eye line is 800 foot, right, plus, but my real direct eye line is 142 feet. And this is because of my eye line making a parallel with mean sea level, because all elevations are taken off with mean sea level, right, proving sea level to be absolutely flat, and proving that this is not possible. The calculations here, they're not possible on a globe, just not possible. Right? All the globe can account for is 76 feet. That's it, right? And they don't have these in their mathematics, these two, visual occultation and optical drop. None of them are part of their mathematics, right? They have to assert all kinds of nonsense that they don't have in their mathematics. They don't have any real refraction in their mathematics. Their mathematics, all they have is 7 over 6R, which is based on the R value, which is based on a measurement to a geometric horizon that we're told we can't see, due to the fact that it's refracted, right? So you can't see the thing that you're supposed to be measuring to get your R value that will give you the refraction that blocks you from seeing the thing that you're supposed to be measuring to get you the R value so you can calculate the refraction that's blocking you from seeing the thing. It's complete and utter total nonsense. This has to end. These people have to wake up, right? They can't account for this observation. No matter what they do, there's no globe way out of this. You've got 76 feet, and them trying to add in refraction will make that less. They have nothing. So please share this as much as you can. I hope it was explained well enough and people get it. You can't, this observation, not only disproves the globe with this observation, but it also shows how this one here is also only possible on a flat plane. Thank you.